The history of the bridge reads like a catalogue of firsts. When it was opened in 1964, the Forth Road Bridge was the longest suspension bridge in the world outside the United States of America. It was the first ever to be built so far north, and it was the fourth longest in the world and the first of its kind in Europe. It is a singular engineering achievement and a proud Scottish icon. It is among the world's longest bridges, using 39,000 tons of steel and designed to withstand the harsh climate of the Firth of Forth.
Probably the biggest change has been in traffic volumes. When the bridge opened in '64, there were 4 million vehicles crossed in the first year. Last year, there were 24 million vehicles crossed the bridge.
It's important to remember that a bridge is a living structure. It has to respond to changes of weather, temperature, and volume of traffic. Like all other suspension bridges, the Forth Road Bridge was designed to be flexible. In fact, it's useful to think of the bridge as a machine with moving parts, expanding and contracting to accommodate the weight of traffic and changes in the weather. For example, a temperature difference of 25 degrees centigrade causes the steel in the bridge to expand or contract, lifting or lowering the main span over a metre in height. To understand how the bridge works, we need to look in detail at its main components. Let's start with the main towers. Rising 156 metres above high water level, the two main towers support the majority of the bridge's weight. They were strengthened in 1998 to cope with the increased weight of traffic now using the bridge. The two main cables reach from shore to shore across the towers. Each is made up of 11,618 individual wire strands, wrapped tightly together to form a 60 centimetre wide cable, weighing more than 7,000 tons. The main cables are anchored into concrete-filled tunnels bored into the rock on either shore, which act like enormous tent pegs, securing 13,800 tons of load in each cable. The entire weight of the bridge deck and all the traffic is suspended from the main cables via 768 steel hanger ropes. These ropes transfer the load back up the main cables and down the towers. This suspended span measures over 1.8 kilometres. Built into the deck under each of the towers are the expansion joints that give the suspended span the flexibility it needs to adjust to weather conditions and traffic loading. The bridge is approached by viaducts on reinforced concrete piers. These are significant structures in their own right, and, when added, make the total length of the bridge more than 2.5 kilometres.